Welcome to Module 4, Plumbing Materials for Water Supply. The pipes, valves, and fittings. First, let's talk about pipes or the piping network for the water supply system. By definition, pipes are a long, narrow, hollow cylinder used to convey fluids, either liquids or gas, from one location to another. So these are used in a variety of fields in engineering, such as plumbing, irrigation, petroleum, and so on and so forth. So I will be talking about the common pipes that are used in the water distribution systems in the Philippines. So there are two categories. There are plastic pipes and metal pipes. Okay, so four common plastic pipes used in the Philippines are the UPVC, CPVC, PPR, HDPE. Don't worry, as right now it's just a bunch of letters, but we'll be going over them one by one. And then we have metal, we have copper and GI. Okay, so first we have the UPVC, or it stands for unplasticized polyvinyl chloride. So this is a plastic pipe now most commonly used for cold water supply lines. So it is made rigid by the omission of plasticizers. So hence the name unplasticized. So these types of plastic pipes are mostly used as home and building cold water supply lines, especially in the Philippines. I guess almost all of you have already seen these type of pipes. These are commonly what is being used in our houses. Or from where we are staying at right now. So what are the advantages and disadvantages of this UPVC or the blue pipes? These pipes are very lightweight. They are the cheapest among all the plastic pipes, and they are relatively easy to install and readily available in almost all hardware stores. But the disadvantages are they're not that strong, so they are easily cracked, especially if they are subject to impacts, or they are uh, stepped on by heavy objects. And then also this is unsuitable for hot water supply lines. Next we have CPVC, or this stands for chlorinated polyvinyl chloride. So this is a thermoplastic pipe produced by the chlorination of PVC. So the previous one is unplasticized PVC. This one is chlorinated PVC. So hence the name CPVC. So this is which the chlorination of the PVC makes it more flexible and can withstand higher temperatures than the standard UPVC. So the CPVC pipes usually come in color beige and with a red stripe along its whole body. So these are often used for hot and cold water supply, either inside or outside the buildings. So what are the advantages and disadvantages of this pipe? So the advantages are it's stronger than UPVC. So this can withstand hot water up to 93 degrees Celsius. So this can withstand almost at the boiling point, because again, in your module 2, you learned that the boiling point of water is 100 degrees Celsius. So this can withstand hot water almost up to that point. 7 degrees na lang ang kulang. Then this is UV resistant, so this can be applied exposed to the sunlight. So that's why it's suitable for exterior applications. The disadvantages is, of course, is costlier, more expensive than UPVC, and the next one, which is PPR. And then hardware stores may not usually stock them, so you might have to do order basis. And then over time, or if the chlorination is not well done, chlorine might get separated and will be dissolved in the water supply. So thereby contaminating the supposedly clean water that goes inside the buildings. So the next plastic pipe is PPR, or polypropylene random. So this is a type of plastic manufactured from polypropylene with a random copolymer raw material. So hence the name polypropylene random. So it is widely used in high pressure cold and hot water plumbing and water supply systems. So which ensures the plumbing to have a perfectly tight system. So let's go on to the the advantages and the disadvantages over these pipes, compared to the other plastic pipes. So the advantages of this PPR is that this is more leak-free than CPVC and UPVC due to the joining methods, or how these pipes are connected. So later on the next module, we'll be talking about how these different pipes are joined together. And this is also more flexible, and this is more readily available than the CPVC, and this is food grade. So there is virtually no chance for contamination from the pipes itself. Like unlike your CPVC, like katong the chlorine, might get dissolved in the water, and then your PVC, since it can't withstand hot water, so maybe it can melt the plastic on the inner walls, and that can also be dissolved through that can also be dissolved in the water supply. So this is the a more safer type of plastic pipe if the application is for food grade. And then the disadvantages of this one is this can only withstand hot water up to 70 degrees. So unlike sa pizza CPVC, which can withstand um, 90 degrees. But for the hot water supply, especially in the use of the toilet and bath, like just hot water for the lavatory and the showers, which is around 40 degrees to 50 degrees. 70 degrees is plenty enough. So you only go above that if it calls from like a special application, like for example chemical labs. And then we also have uh, a disadvantage. The second one is more complicated joining method. uh, because the advantages is that it can is more leak free, so this is less susceptible to leakages. The disadvantage that is because of that, it has a more complicated joining method compared to the other plastic pipes. And then this is not UV resistant, so this cannot be exposed to sunlight or exterior applications because this will degrade over time. So this PPR installation should be inside or concealed. So HDPE pipe is a thermoplastic made from high density polyethylene. Polyethylene is a kind of plastic. So HDPE has a high level of impermeability and strong molecular bond, making it suitable for high pressure pipelines and industrial applications. Now, HDPE pipes are also used across the globe for applications such as water mains, community water distribution, in conjunction with GI and uh, in some instances steel water pipes. So if you take a look outside, your houses or from where you're staying at, most probably um, the pipes supplying each into the individual homes are either GI or this HDPE pipes. So usually they are colored black pipes. Sometimes with a blue strip, sometimes without. But if it's a black pipe, and it's kind of flexible, there's a good chance that is a HDPE pipe. So now let's talk about the advantages and disadvantages of HDPE. So again, this is the strongest, of all the plastic pipes that was previously mentioned. It is industrial grade, it is food grade, it is UV resistant, and it's flexible. So that's why this is also used. This can be used for pipes for water distribution within the community. And sometimes you can see this on the side of the roads. It's color black. The disadvantages would be, again, this is the expensive. No, this is the most expensive out of all the plastic pipes, and it also has a more complicated joining method, and it is difficult to bond. Now, again, we'll be talking about joining methods on the next module. Now let's talk about metal pipes. So there are actually a bunch of metal pipes. So we'll just talk about two, as this is the one that is more common. And for water distribution, there are metal pipes that are used for the drainage systems, which we'll be talking about on a later part of this course. So copper, no, we don't usually use this in the Philippines mainly because it's uneconomical and impractical. This is more widely used in US and Europe, but it's still worth mentioning. So there are three types of copper pipes indicated by a letter, from type K, type L, and type M. So type K is the heaviest and thickest. So this is suitable for underground and main water lines. Then we have type L, lighter and thinner than type K. These are mostly used in residential water supplies. And then we have type M. This is the thinnest and lightest, so designed only for small water supply lines, like the pipes going into the fixtures already. What are the advantages and disadvantages? So again, since this is a metal pipe, this is very durable. No, excellent pipe for hot water lines. No, then it's also corrosion resistant and fire resistant. Then the disadvantages is that it is expensive, very expensive. That's why I mentioned earlier that it's uneconomical because it can cost up to 10 to 15 times more than plastic pipes. No, it's unwise to invest in copper pipe in piping, especially if you don't see it. No? Usually our pipings are concealed behind the floors, behind the walls, underneath the soil. Why spend that much when you could achieve a good piping system with much cheaper using plastic pipes? Okay, and then requires a more skilled worker to install. So it has a very specific joining method. Then we go to the next one, the GI or the galvanized iron pipe. So this is very common in the Philippines. So it is an iron pipe which has been galvanized to prevent it from rusting. So galvanized iron pipes are widely used for distribution of potable water. So this is um, the pipes used by MCWD for individual distributions to the homes and the houses. Excuse me. Also, when we talk about galvanized, it has already undergone galvanization. So this is the process of coating iron or steel in zinc to make them corrosion resistant and rust free. Because again, metal is susceptible to rust. So if this is just plain iron, like black, um, then it is susceptible to rust and therefore cannot be used for um, water supply. Then now you might ask, no, so I'm sure some of you have seen galvanized iron which has actually rusted. Now that's because usually when these GI pipes rust, it's because the galvanization process has not been done uh, properly, or sometimes the GI pipe has already just reached its lifespan. So what are the advantages of GI pipes? So GI pipes are they're cheap, they're UV resistant, and they're impact resistant. They're also heavy, labor intensive because they're metal, may rust again if not galvanized properly, and this is also unsuitable for hot water. So usually GI pipes are mostly used for exterior applications. No, then the piping system will just switch to the plastic pipes once it goes inside into the houses or buildings. Now let's move on to the second part of this module, which are the fittings. So fittings are joints in the pipe systems for when A, connecting pipes, B, when there's a change in direction, C, joining pipes of different sizes or materials, and D, for measuring or regulating flow. Now we will go over the common fittings used in the water distribution system. So we have eight now common fittings, and each of these pictures represent a material based on their color or texture. So we have elbow, a T or cross T, the coupling, reducer, the nipple, the cap, the plug, and the union. So elbow is used when a change in direction is needed. So a change in direction in either 90 degrees, 45 degrees, and there are also elbows that are 22.5 degrees. So In this image right here, obviously this is a 90-degree elbow. So if you need to change the pipe directions, maybe because there's an obstacle or it already hit a wall, then of course you need to use elbow fittings. No? Of course, this is because even though some plastic pipes are flexible, no, they're not really meant for sharp. They're not really meant for sharp turns and corners. No? So we need to use fittings in order to manipulate the piping system to fit, the house or the building. Then we have T or cross T. So this is a fitting having 3 or 4 outlets forming a T or forming a cross. No, so these are used in dividing the water flow in 3 directions if it's a T and 4 if it's a cross T. Then next we have coupling. No, so it is a short length of pipe with openings on both ends that allow pipes to be joined together. Okay, so for example, most pipes are usually sold, no, in either 4 meters or 3 meters in length. Now, of course, our buildings or houses are not that short, no, so they span several meters more. So of course, we need to combine these pipes together to make it longer. One way to do that is to use a coupling. So in this coupling, this is a GI coupling. No? So you just thread one pipe in this part here, and then also thread another pipe on the other end. So they're now connected. Oh, by the way, this is a UPVC. This is blue. This is a PBR because it's green. This is GI, and this one, the reducer. This is an HDPE reducer. Now, what are reducer fittings? So, reducer fitting class are any of the fittings, no, that join multiple pipes with different diameters. So, in this image right here, this is a reducer coupling, no, because the pipes run in a straight direction. The only difference is that it joins a pipe of a larger diameter to a pipe with a smaller diameter. So that's why it's called a reducer. No, so there are also elbow reducers, T reducers, no, wherein one end or one opening of the fitting is smaller than the other. Then next we have the nipple. So the nipple is a short length of pipe with outside threaded ends, that allow pipes to be joined together. So this is specifically a GI nipple. So this is the male counterpart of the coupling. So in the coupling class, the threads are inside, so that the pipes go inside. No, so this is a female fitting. No, I guess I don't need to explain what is a female and a male um, fitting. No, I guess all of you are above 18 already, so I'm assuming you would understand. And then for the nipple, this is the male counterpart of the coupling. So the nipple will actually go inside the pipes that are to be connected. Okay, and then next we have the cap. No, so this is an female fitting, no, with inside threads used to seal open ends or dead ends of pipes. No, so there are mga dead ending of pipes. No, you can use a cap to seal it off by threading, or by threading it, or it depends on the material. And then we have a plug. No? So this is the male counterpart of a cap. So if the cap receives the pipe, the plug is the one that inserts itself into the hole of the pipe. And then the last one, we have a union. So similar to a coupling, no, but it is used when uh, you are trying to join two pipes that are already fixed in position, like for repairs. No, like for example, a pipe's burst and you need to replace a section of it. Of course, you can't turn it already because but at the opposite ends, it's already fixed. No, so of course you can't use a coupling because to tighten a coupling, you need to twist the pipe. So in the union, this part here is the one you'll turn for it to be tightened, to form a seal, so that there's no leakage that will occur. Now let's go to the last part of this module, so which are valves. So valves are plumbing appurtenances used in plumbing systems to either regulate, direct, stop or control the flow of fluids. Okay, so these are the valves, that are commonly used in the water distribution system, as far as houses or residences go. So we'll be talking about six of them. So we have the gate valve, the ball valve, the check valve, the float valve, the globe valve, and the angle valve. So the gate valve now is used to completely stop or completely open the flow of water by means of a gate being lifted or lowered inside. So when the gate valve is closed class, this gate right here is lowered, thereby preventing the flow of water from from getting across. But if you turn the hand wheel and the gate valve is open, and the gate is now placed in this position, thereby freeing this spot here for the water to go freely across. So a ball valve, is a valve that controls the flow of water by turning a perforated pivoting ball. So as you can see, that is the ball right there, and this. So it is open when the ball's hole is in line with the flow of water, like in this image right here, this section, and it is closed when it is pivoted 90 degrees by the valve handle. So as you can see from the right image, like the gate valve, it is designed to be completely open or completely closed. Now, having this valve, neither of those two, so maybe you left it slightly open or slightly closed, that can damage the valve over time, simply because they're not designed to be that way. There is a specific valve for that, where you can leave it slightly open or slightly closed, which we'll be talking about later. So the next one is a check valve, or one-way valves. Now, these are designed to prevent the backflow of water, to prevent cross-contamination. So the pressure of the fluid through the pipeline or inside the pipe pushes these um, pushes this as a barrier here, so that it swings open, okay, and so that the water can now flow freely. But of course, the water cannot flow. There's no chance for the water to flow back, because from the pressure from going back will subsequently close the valve. Okay, so that's how this check valve works. Now, check valves are also not really manually operated, so they're sort of mechanically automatic. A float valve or ball cap is a valve for stopping flow of water, usually inside water tanks, once a desired level of water is reached. So their primary purpose is to automatically stop the flow of water once the level of water reaches a desired position inside the water tanks. So if you compare these two images right here, now if the water level is high, or if the water tank is full, the flatter angle of the ball cap closes the water inlet. But if the water level is too low, or it's not full, the the steeper angle of the ball cap opens the water inlet. Okay, so as you can see from this image here, if this is the angle, and the direction of the float valve goes like this, depending on the level of water. Okay, so globe valves are used to regulate or throttle the flow of water in plumbing applications. So the valve operates a disc, this one, that is lifted and lowered as the actuator or the handle is rotated. So this type of valve gets its name from the bulge, in the body of the valve. So this looks similar to a gate valve, but again, the telltale sign that it's a globe valve is because of this bulbous form. So unlike your gate valves or ball valves, these are used to globe valves are used to throttle the flow of water. So this time you can leave it slightly open or slightly closed, and this will not get damaged over time. Next, the last valve, the angle valve. So these are called shut-off valves, with sometimes a 90-degree outlet, and is used to stop the flow of water to the individual fixtures like lavatories and water closet. Now, these valves are used to isolate specific fixtures, especially when you're doing repairs. So you don't have to turn off the whole supply of the building just to repair one fixture. So you can just, so if there's a problem with the lavatory or the water closet, now you can just shut off this valve now um, from when repairing and not affecting the other fixtures that are fine. Okay, not cutting off the other fixtures water supply. So these are used in again in lavatories and water closets, no? So I'm sure you can find this in your houses, no? So try to find the angle valves of your lavatories and water closets, no? And try to operate them, close and open